Next is position vector. Let vector x is equal to x1, x2, x3 belongs to R cube be a vector and a point P in space having coordinates x1, x2, x3. The directed line segment OP with initial point O and terminal point P is called position vector of point P and is denoted by OP. Thus, the position vector of P is vector x is equal to x1, x2, x3, that is OP x1, x2, x3, and if the position vector of a point is vector x, then OP is vector x is a geometrical representation of the vector. So as if A is x1, x2, x3 and B is y1, y2, y3 are two distinct points in R cube, the vector joining the point with initial point A is AB and the position vector AB are y1 minus x1, y2 minus x2 and y3 minus x3. So these are the position vector of AB. Now we are going to state theorem 6.3, whose first part is every vector of R square can be uniquely expressed as linear combination of vector I and vector j. Now the proof is, suppose vector x is x1, x2 belongs to R square, that is ordered pair. Then vector x can be written as x1 into 1, 0 plus x2, 0, 1. That is x1 unit vector in the direction of x-axis, x2 unit vector in the direction of y-axis. So thus vector x is a linear combination of I and j. Now we have to prove uniqueness. Let vector x is equal to x1, x2, which is equal to, in the another form, pi plus qj vector. So we can write p1, 0 plus q 0, 1, value of I and j unit vector. So we get p, 0 plus q, 0, that is 0, q. So we get p, q as x1, x2 is equal to p, q. That implies x1 is equal to p and x2 is equal to q. That is vector x is equal to x1i plus x2j is equal to pi qj. That is vector x is equal to x1i plus x2j is a unique representation of vector x as a linear combination of vector I and vector j in the direction of x-axis and y-axis. Theorem 6.3, second part. Every vector in R cube can be uniquely expressed as a linear combination of vector I, vector j and vector k, as we done in the case of R square system. So the proof is, suppose vector x is equal to x1, x2, x3 belongs to R cube. Then vector x is equal to x1, x2, x3. It can be rewritten as x1 into unit vector in the direction of x-axis plus x2 into unit vector in the direction of y-axis, x3 into unit vector in the direction of z-axis. That is x1i, x2j, x3k. So this is x represented in the form of I, j and k. Now we have to prove uniqueness. If vector x is equal to pi, qj and rk. Now substitute the value of I, j and k. That is p 100, q 010 R001. So we get P00 plus 0Q0 plus 00R. So we get P, Q, R as vector x is equal to x1, x2, x3, which is also equal to PQR as proved above. So by equality law, vector x1 is equal to P, x2 is equal to Q, and x3 is equal to R. Therefore, vector x is always written as x1i, x2j, and x3k. That is in linear combination of I, j, and k in unique form. So this was a theorem in RQ space.